Hello team, this is sum of squares where we're given an integer up to and including 1000 and we need to return the sum of all the integers squared. So in the case of 5, it is 1 times 1 plus 2 times 2 plus 3 times 3 plus 4 times 4 plus 5 times 5, right? We square each of those and then we sum them up to get 55. And if we do that all the way up to 1000, we get this really big number, right? It all makes sense, hopefully, where we are just summing up the squares of each sum, each number up to and including whatever n is, right? At first glance, I like the factorial solution that we had, right? Where we did some recursion. We absolutely could do that. So we could go n times n plus sum of squares, just like this, n minus 1, we needed an escape hatch. So if n is less than equal to 1, then return 1, right? That's what we're trying to do there. And we should probably have an error for negatives, right? Just like the factorial solution. So right there, we have it all. It's all working, and it does work, right? And of course, if we really wanted to lock this in, we could change this to be a proper exponent, right? So to the power of, that's what that is, or we could use math.pal, right? All those are in there. But the recursion, we talked about this recently, where at some point we're going to hit our max call stack. And the reason for that is because whatever n is, that's how many calls we're doing to this function, right? So if we do 10,000, if n is 10,000, we're only guaranteed 1,000. But if somebody plugs in 10,000, then we are going to do 10,000 calls to this method, right? And there's a call to, or there's a cost to calling the method. So setting it up, tearing it down, all that stuff, it goes through the call stack. And at some point, it will throw errors because it's just too much. So is this great? No. Is it fun? Yes, absolutely. I love using recursion. But we should do it a different way, which means that we should try again, okay? So right here, I'm going to go let sum. It's going to be equal to 0, right? We're going to add to it. And right here, we're going to set up our for loop. It's going to be let I equal 1, right? There's no reason to start at 0. We always want to return at least 1. That's what this is doing here. So we're going to do that. And then, of course, I is less than equal to n and I plus plus, right? And then we drop into our loop and we go sum, which is adding, right? That's what we're doing with the adding here. N, not n, sorry, I times I, okay? And then, of course, return sum, just like this. And again, it all works. Again, we could clean this up a little bit. So we could go times 2. It all works, right? Now, if you have a better memory than me, you could memorize the closed form formula, right? Of which there is one. So we could grab this again, right? Bring it down, clearing this out so that we can actually see past that error message, and deleting all of this, right? Maybe we still want the error message, maybe we don't, but what we should do is we should return n times n plus 1 times 2n plus 1, which absolutely doesn't work, right? We need to wrap that up, and we need to put a times in here because it doesn't do it that way, right? So 2 times n plus 1. Why is the m in there? I don't know. So n times n plus 1 times 2n plus 1, all divided by 6, and it works. How did I remember that? Well, I have a cheat code, right? Just off to the side of the screen, I have that formula written, and I can see it in my peripheral. I'm probably never going to remember that if this comes up in an interview question, but I will definitely remember this one, right? And if I'm having a little bit of fun, maybe I do go for the recursion. And I mentioned that at some point it's going to throw an error because of the max call stack, right? Again, 3 options, not every solution, just 3 hopefully pretty good solutions, right? Let me know which one you like, which one you hate, right? If you went a different way, let me know all that good stuff. Otherwise, for today, this has been Sum of Squares, and I will see you tomorrow.